Okay, now that we have learned a little bit about the linear growth model, let's look at what the actual model is. Up here in the top corner of your page or somewhere on your sheet of notebook paper, please write down that P's of n, that's how we read this, P's of n equals, this is a P's of 0 plus D times n. Please write that down. You notice the P's of 0 is your start or initial value, that's here in blue. The D is your common difference, that's here in red. And the N stands for your term, which will make more sense once we actually do a problem. I'm going to work out a couple of these problems that was on your paper. Let's do a couple together. I'm going to do maybe the easiest one, the hardest one, and then a couple in between to try to get you started. Let's start with number one, probably the easiest one on the page. So notice the directions for this are all the same. For number one, you're trying to find an explicit description. That means you write it in this form for the population. And then number two, find the 9th generation of the population. So let's do the first part first. So my equation is P's of n equals my initial. My initial is P's of 0. It's 718. So 718 goes first. Plus D. D is my common difference. My common difference is 32. So plus 32 times n. N stands for whatever term I'm looking for. So for the second part of each question, it says, now that you know that equation, use that equation to find the 9th generation. You're going to do the same thing for all 8 of these questions at the top. You're going to plug in 9 to your formula. So I'm simply going to take my calculator. I'm going to do 718 plus 32 times 9 and see what I get. We get 1006. So that means that P's of 9, the 9th generation, is 1006. Let's do another one. Notice in number 3, it's a little bit different because just like how in number 2 and number 4, you are not given what your first term is, but you are given a list of numbers. Well, you can assume if you're given a list of numbers, the first term is your P's of 0. This is my P's of 0. So that means that when I write my formula, P's of n equals, I'm starting with 1,123. What I need to find is the difference. What is the difference between this term to the next term? So I'm going to take a calculator and I'm going to simply subtract 1332 and I'm going to subtract 1123, the number before it. It gives me a difference, as you can see there, of 209. That means that I'm adding 209 every time. If you're not sure, take 1332 and add 209 to see if it gets you 1541. It does. So you know your common difference is 209. That means I'm going to add 209 n. Again, n stands for term. So now we're going to use that n and plug in, just like the directions say, find the 9th generation. So now I'm going to plug in 9 for that n. So I'm going to do 1,123 plus 209 times 9. And it gives me 3,004, 3004. So that means that P's of 9 is 3004. Number 2 and number 4 are exactly the same. This is your first term. Find the difference to find what your term would be for your D. Let's look at your right column. These are slightly different. So you can do these one of two ways. You can do these by hand, or you can use these using a calculator or a Desmos. Let's start with number 6. So number 6, you don't know the initial term. You know the 13th term, you know the 14th term, but you don't know the 0 term. So the 13th term is 96, the 14th term is 105. So what I would do in an example like this is you can solve this by hand by figuring out what the common difference is. Notice you get from 96 to 105, you are adding 9. So your common difference is going to be 9. But then you have to figure out, well, if the 13th term is 96, I need to find out what the 0 term is going to be. So I would then need to subtract 9 once to make it P's of 12, again to make p's of 11, again to make p's of 10, and go backwards all the way till we get to p's of 0. What I think is easier is to use a calculator or use Desmos. So I'll show you both. Number 6, let's use a calculator. So all I'm going to do is I'm going to go to my calculator screen. I'm going to hit Stat, Enter. If I have any numbers in there, I'm going to clear them out. My Stat button is right here in the middle, right below the Delete button. And I'm going to type in my numbers. So when p is of 13, I have 96. When I have p's of 14, I have 105. Notice how 13 and 14 are in the columns, 96 and 105 are in the columns together. So then hit the same buttons every time. I'm going to hit Stat. You probably know this already. I'm going to arrow over to my Calc menu, and I'm going to hit option number 4, which is a LinReg. LinReg means a linear regression. That's what a linear growth model means. So again, that was Stat, arrow over to Calc. I forgot to hit 4, and hit option number 4, LinReg. Hit Enter, and there's your answer. So that would be p's of n equals, this is just like slope-intercept form. What you are doing is basically a senior level version of slope-intercept form. This is like y equals mx plus b, but you're doing this on a senior level. So let's take this and rewrite this. You can put 9n minus 21 if you want to, but since we've been writing all of them with the initial term first, I'm going to put negative 21 as my first term because that's my initial term. I'm going to write that first. And then 9 is my common difference, so I'll put 9 after it. So negative 21 plus 9n. And then just like for all the previous questions, I'm going to find the second part by plugging in the 9th generation. So I'm going to plug in 9 for n. So negative 21 plus 9 times 9. And it gives me 60. So that means that p's of 9 is equal to 60. So it's a little trickier. Let's do the hardest one on the page, which is probably number 8. It's a little trickier when those numbers are more spread out. Let's say instead of having 13 and 14, you had term 21 and term 90. So not only do you not know what the common difference is, but you also don't know what the initial value is. So let's figure this out using this question here. Again, I'm going to start out the same way with p's of n equals. Let's figure out what's going to go there. This time, let's use Desmos. We use the exact same numbers, but this time, instead of typing in the calculator, let's type it in Desmos. So here's how that works. First of all, go to desmos.com/calculator. You're going to hit your plus sign, which is up here. You're going to add a table, just like you did when you were doing it in your calculator. All right, so when you have 21 in your first column, it matches up with 2170 in your second column. And then 90 matches up with 5896. Go down to your second line, and you're going to do slope-intercept form, y equals mx plus b, except you're going to change things a little bit. You want to be able to tell the computer to use the y1s. When you type in y, hit a 1 after it. Instead of hitting equals, hit the tilde sign, which is right next to the number 1, right below the escape button. And do mx. Again, you want to show that you want to do this x value, so x1, and then plus b. Your answer is down here, 54 and 1036. 54 is your m, that's your common difference. 1036 is your b, that's also called your initial value. Let me write those both down on my paper. So number 8, I would write that as p's of n equals 1036 plus 54n. And then again, like always, I need to find the 9th term. So to do that, I'm going to take 1036. I'm going to add 54 9 times. So that means the 9th term, p's of 9, is 1522. So my final answer is 1522 for my 9th term. Let's look at one of your word problems at the bottom. Let's look at the first story problem with number 9. So here's where you can actually use a question like this, especially when you get to lab populations like number 10, or when you try to predict your sales if you want to own your own business, which I'll try to talk more about in class the next couple days. So number 9, Marcus is a snappy dresser, has an incredible collection of neckties. Every 3 months, he buys himself 4 new neckties. So this is your transition. This is your generation every 3 months. So that is equal to your N. He buys himself 4 new neckties. So that's your common difference. Let P's of 0 represent the number of neckties you start with. P's of N is the number of neckties in his collection at the end of the nth 3-month period. Assume he starts out with 3 neckties, so that's your P's of 0. And he never throws away 1. Letter A, what is the population in this problem? So what is changing in this problem? What is changing is the amount of neckties that he has. So letter A is simply neckties. Letter B, what is the transition? So the transition, it says up here, we underline it, every 3 months. So the transition is 3 months. And then letter C, what is the transition rule? So P's of N equals, well, what does he start with? It says he starts out with 3 neckties. So P's of N equals 3. And every 3 months, he buys himself, if he's buying himself, he's adding more to his collection, 4 new neckties. So he's adding 4 N. You could use that formula. It doesn't ask you to, but you could use that formula if you wanted to figure out how many neckties would he have in 9 months. Well, 9 months would be 3 transitions because 9 divided by this 3 is 3. So you plug in 3 for there. 3 plus 4 times 3 would give you a final answer of how many neckties he has at the end of 9 months. I hope that was helpful.